morning. In today's class, we will consider the case of condensed explosives. When we say condensed explosive, all what we mean is the explosive substance exists either in a solid phase or in a liquid phase. We have already considered, like for instance, explosives involving fuel gas and air mixtures or fuel gas and oxygen mixtures. We also saw dust with air, and what we do today is solid and liquid explosives. By explosives we mean it essentially consists of fuel and an oxidizer, and this fuel and oxidizer could either be mixed together to form a mass of an explosive, or else the fuel and oxidizer could form a compound, like it could be as a molecule, as a chemical substance. Therefore, we consider both these cases, and therefore, in order to consider an explosive, maybe a condensed explosive, which we say being in liquid or solid form has a higher density, and therefore its potential for causing damage is much more. That means it's much more powerful than maybe the dust explosive or the gaseous explosives which we considered. Therefore, we take a look at what are the fuels and oxidizers which comprise of the solid explosives, and to be able to put things together, I think some clarity must be required on the fuel part of the condensed explosive, on the oxidizer part of it, and we recognize that most of the condensed explosives are derived from organic substances, namely hydrocarbons. But we will also consider, there are a few inorganic explosives, we will also consider them. In today's class, we restrict ourselves to those explosives coming from the hydrocarbon fuels. We will also look at oxidizers, and then we will put both the things together and come out with what are the different types of explosives. Let's take a look at the hydrocarbons. I think if we can have a classification of different types of hydrocarbons, and then for this particular classification, if we know what oxidizer to introduce where, we come out with explosives, and it's very easy, and the number of such explosives, both organic as well as inorganic, are not many. There are just a few of them. Therefore, let's get started with the hydrocarbon fuels. And when I say a hydrocarbon fuel, well, carbon and hydrogen are central to it, consisting of hydrogen and carbon. When I look at carbon, well, carbon, if you see as an element, it has an atomic number of 6, it consists of 6 electrons. In the inner shell it has 2 electrons, in the outer shell it has 4 electrons. Therefore, let us say carbon has, 4 electrons on the outer shell. Now, to be able to have a stable shell, it needs 4 more electrons, such that on the outer shell you have 8 electrons. And what does it do? It tries to share maybe an electron with some other substance. Let's say hydrogen is a substance which has 1 electron on the outer shell or orbiting around its nucleus. Therefore, if it can share this electron which is available in it and this electron, it could share with another hydrogen atom another electron, it could share another hydrogen atom, it could share 1 more, and it could share 1 more over here. Well, the outer orbit becomes 8. Therefore, it is possible for the carbon atom to combine with hydrogen atoms by sharing a pair of electrons, and when it shares a pair of electrons, we say it is a single bond. It need not be hydrogen alone, it could also share the carbon atom could share an electron with another carbon atom, and this is also, we say, is a single bond. When 1 pair of electrons are shared, we say, well, the bond is a single bond. Well, it's not necessary that it always shares 1 carbon atom sharing 1 with hydrogen, or another 1 electron from this carbon atom sharing with this carbon atom, one from this, sharing this, forming a single bond. It's also possible for carbon atoms to share two, that means a pair of electrons, two pairs of electrons. That means I have 2 from this is shared between this and this is shared between this and this and this. That means 2 pairs of electrons are shared, in which case we say it is a double bond. In other words, I can show this double bond as carbon sharing 2 pairs of electrons. Similarly, I can also think in terms of maybe carbon, we said has something like, we said 4 electrons on the outer shell. It could share with another carbon atom maybe 3 of the electrons, in which case we say that the bond is a triple bond. You know, as the bond number increases for a triple bond, what is going to happen? It's going to be a little unstable because it is sharing more, whereas this is more stable. And when we say single bond substances are generally saturated hydrocarbons, whereas maybe when you go to double bond and triple bond, we call them as being unsaturated hydrocarbons. Now, you know, it is not necessary that you have only one double bond. It is possible for you to have 2 double bonds, and when you have 2 double bonds, like for instance, maybe you have 2 double bonds alternating with each other. Like for instance, let us consider a substance over here wherein I have something like a bond like this, a single bond followed, or a double bond followed by a single bond followed by another double bond. Well, you know, in this case I have 2 double bonds, and such substances also exist. Therefore, let us classify these substances. Let us take some examples and put these things together. When the carbon atom has single bonds, namely I have carbon with hydrogen atoms over here, H, 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 H. Well, I form methane, or I call it as methane. Maybe I could have single bond over here, two carbon atoms, well, linking to the hydrogen over here, hydrogen over here, hydrogen over here, hydrogen, hydrogen over here. Namely, I have something like C2, I have 3 plus 3, 6 over here, H6, and so on. Therefore, these are all single bond substances. I have something like methane, I have ethane, and you find, you know, I could also have propane, C with hydrogen at the ends of this. All places you have hydrogen, it gives me C3H8. I have butane, which is C4H10, and so on. And in general, when I have these single bond substances, the general formula could be CH4, C2H6, C3H8, C4H10, which is equal to Cn H2n plus 2. These single bond substances are known as alkanes. As distinct from these alkanes, whenever I have these double bond substances, well, let's take a look at a double bond substance. Well, I have the carbon atom over here. It is linked through a double bond with another carbon atom. Well, it has a valence of 4. I need to get the valence of 4. And therefore, well, over here I have 1, 2, 3, 4, 1, 2, 3, 4. I have something like, let's say, CH. Instead of this, I can draw it over here, H over here, H over here, H over here. I talk in terms of C2H4, which we call as ethene. Compared to ethane, it is ethene. Compared to propane, if I have here, now I am talking in terms of maybe one double bond. Therefore, if I talk in terms of one double bond, I have H over here, I have one H over here, I have one H over here, I have one H over here, and maybe one H over here. I have something like C with 4 of them, 1, 2, 3, 4 over here, 1, 2, 3, 4 over here. No, 1, 2, and 2, 4 over here, which means it is equal to C3, 1, 2, 3, 4, 5, 6, C3H6, which is propene. And the general name given for substances having one double bond is what we call as alkenes. You know, these alkenes are not fully saturated, like what we said, it is all single bonds, and these are unsaturated, and it is also known by the name olefins. We can keep going like this. I could have alkenes like ethene, propene, butene, and so on. And when we come to the third category, namely the triple bond substances, when I say triple bond, well, I have C, and therefore I just need one H over here, one H over here, I have four over here, and therefore this particular substance having a triple bond is known as acetylene. The general formula or the general name for triple bond substances having one triple bond is known as alkynes. And you see, the triple bond will not be that stable, and we did see acetylene in our previous study of the gaseous fuels and involving with oxygen. We found its ignition energy is very low. It has a higher level of maximum overpressure in a constant volume explosion. We also saw that the dP by dt value, or the type of severity of the explosion was higher, and this is what is acetylene, maybe with the triple bond over here. Therefore, we generally classify hydrocarbons as either alkanes, alkenes, or alkynes. And let us go to the last one. When I have two double bonds alternatively occurring, the substance is known as alkadine. What is this alkadine? It's also something which occurs very frequently, and therefore we must be very clear about it. And what is an alkadine? Let's say I have butane. Butane is something like CCC, and if I say butane, well, this is the formula for butane. Now, if instead I have one double bond over here, well, in this case I don't need this, and I have another double bond over here, well, I don't need this. Well, I have something like two double bonds over here, alternate two double bond. This is known as butadiene. It is an alkadine. That means a substance having two double bonds is what we call as a butadiene, and a typical example is typical example of an alkadine is, let's say, butadiene. It could be pentadiene, and so on and so forth. Therefore, we say whenever we are talking of these chains, we are talking of chains which are straight chains over here, straight chains over here, straight chains. And whenever we are talking of these hydrocarbon chains, which are essentially single bond, a double bond, a triple bond, and these substances having single, double, and are substances which we can say a hydrocarbon substance having single bond giving alkanes, having double bond giving alkenes, a triple bond giving alkynes, and maybe two double bonds giving alkadines, right? These are the typical things, and these are all straight chain substances. But there is nothing to keep the straight chain always straight. It is also possible for us to have bent chains. Like, let's take an example of propane. We take propane, CCC, have hydrogen here. We are talking of propane, which is an alkane. In this case, maybe, I can write this as maybe 1H into C. Let's put hydrogen into this, HH, HH, HH over here. I have hydrogen over here. I can put this C, CH2. I have another CH2. I have another CH2 and H over here. It is quite possible, instead of having this as a linear system, I can have it as bent chains, something like chain. Instead of being straight like this, that means I have CH2 over here, I have CH2 over here, I have CH2 over here, and this is known as a cyclo. That means I call it as cyclo of the propane, or I call it as cyclopropane. Or since I am considering alkanes, I could have, for alkanes, I could have a cycloalkane, I could have cycloalkene, I could have cycloalkynes, and I could also have cycloalkadines in a different form. Let us take one more example of a cyclo chain. Let us consider hexane. When we say hexane, I am thinking in terms of 6, 2, 4, 5 and 6 carbon atoms. That means 6 corresponding to hexane. This is my normal hexane, what I have, right? And if I want to form cyclohexane, what is it we do? We have something like a bent chain. The bent chain consisting of the 6 carbon atoms is going to be CC, 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 and what is it I get? Well, I can write this as CH2 with hydrogen over here, CH2, CH2, I have CH2 corresponding to this, I have another CH2, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and the last one CH2 and H over here. Therefore, this gives me something like CH2, 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 CH2 and CH2. Well, this is the cyclo form of cyclohexane, and mind you, we did talk of an explosion involving cyclohexane, namely the Philipsborough accident in UK, in which we said that the explosion was so strong involving cyclohexane that the entire township of Philipsborough became something like a ghost city. But in addition to these straight and bent chains involving normal, that is straight chain, and the bent chain substances involving the cyclo radical, we also have another radical which is known as a benzene substance, benzene radical. All these substances are known as aliphatic substances. Whereas, compared to these aliphatic substances, we also have another form in which hydrogen and carbon combine together to give substances known as a benzene radical. This benzene radical is somewhat similar to this cyclohexane in that it has 6 carbon atoms, here 1, 2, 3, 4, 5, 6, and you have CH2, that is H2 attached to it to give you cyclohexane. But here also you have something like 6 carbon atoms. Let us put it together. I have 6 of them in a ring compound. But the difference from cyclohexane is it has 2 alternate double bonds. I have a single bond, let us say a double bond over here, a single bond over here, a double bond over here, a single bond over here, a double bond over here, and a single bond over here, and this is attached to the carbon atoms over here. This particular radical having 6 carbon atoms with alternate double bonds is known as the benzene chain or a benzene radical. And this particular benzene type of substances, or substances having the benzene radical, have a very strong flavor, nice smelling substances. That means they have something like an aroma associated with them, and these are known as aromatic substances as compared to these hydrocarbons which we say are aliphatic substances. Therefore, we again have a classification. We can say the hydrocarbons could either be aliphatic, and these aliphatic substances are known as paraffins also. It could be substances having the ring type of structure with alternate double bond with 6 carbon atoms. Those are known as aromatic substances, and such type of benzene rings are also associated with hydrocarbon fuels, and they also contribute to forming different types of explosives. They can also combine with oxygen. Well, it is not that I can have only one benzene radical. It is possible for me to have 2 benzene chains together. Like for instance, I have 6 carbon with a double bond. This is my benzene radical. Double bond over here. I have a single bond over here. I have a double bond over here. I have another carbon. And now I could have 2 such things together, 2 such benzene chains together. Like for instance, I have another C over here. I have another C over here. I have another C over here. I have C over here. I have a double bond over here. Therefore, I have 2 benzene radicals over here combined together, and this is known as naphthalene. I could similarly have 3 such things together, which is known as anthracene. We would have heard of these things, some of them are poisonous like anthracene. I have 3 of them together, 1, 2, 3. I have naphthalene. We use naphthalene in our cupboards to protect maybe clothes from insects, because it has a strong aroma. All these benzene substances have strong aroma. Therefore, we talk of hydrocarbon. Therefore, let us come back to where we got started. We said, well, I would like to understand a little bit more about fuel such that I can talk about the explosives, and therefore we say, well, a hydrocarbon fuel could either be aliphatic or it could be aromatic. And in aliphatic, we had a series of things like we talked in terms of alkanes, alkenes, alkynes, and alkadines. In aromatic, we talked in terms of benzene, maybe naphthalene, maybe anthracene, and so on. Therefore, let's quickly summarize this before we talk in terms of different oxidizers and how these oxidizers could combine with these individual substances. Therefore, I show this particular classification in the slide, and what I show is, well, the hydrocarbons could either be aliphatic substances or aromatic substances. Aromatic substances have a very strong flavor or a smell, and they have the benzene structure. And the benzene, it could either be a benzene structure, it could be a naphthalene, in which case I have 2 of these benzenes, I could have anthracene. When we talk of aliphatic substances, it could either be saturated, in which case I have only straight chain substances, and these straight chains are some things like methane, ethane, propane. I have cyclo chains, in which case I talk in terms of cyclopropane, cyclohexane, cyclobutane. I have things which have a single double bond. Single double bond are alkenes, which are also known as olefins, and these olefins could be a straight chain, like I have ethene, propene, pentene, and so on. I could also have cyclo, just like I had cyclo in the saturated one. I could have straight chain and cyclone. I could also have straight chain and cyclo. I could have alkynes. Alkynes we said is acetylene. I could also have cycloalkanes, and we could also have alkadines, in which case I have 2 double bonds, and in which case again I could have straight chain alkadines and cycloalkadines. This is about all the fuels we have, and therefore now I would like to have some understanding of what are the oxidizers, and in how does an oxidizer combine with the hydrocarbon, and what are the type of explosives what you get. Therefore, let us go to the oxidizers, and the type of oxidizers what we have are, but we find the oxidizers which are used with the condensed explosives are either nitrate or nitro compounds. What do you mean by nitrate? By nitrate we mean ONO2 radical. By nitro compound we mean NO2 radical. Therefore, we normally combine this, and for the particular case with which we are talking today, namely the organic substances involving hydrocarbon fuels, namely the explosives derived from hydrocarbon fuels, we are talking in terms of maybe either a nitrate or a nitro compound combining with any of the substances which we just talked just now, maybe alkenes, alkynes, alkadines, and so on. Normally what happens is ONO2 is used or combines with linear chain hydrocarbons. That means we are talking maybe of alkanes, alkynes, and alkadines in the straight chain, whereas NO2 oxidizer combines with cyclochain involving alkynes, alkanes, alkenes, alkynes, and also alkadines, and also with those having, let us say, we called it as aromatic chains. That means those involving benzene. Therefore, we will try to see how ONO2 and NO2 combine, and therefore, on the basis of what we discussed for the different hydrocarbon fuels, namely the aliphatic and aromatic, let us find out how the explosive is formed. Let us begin with methane. Methane we said is CH4. All what we do is maybe we take one of the hydrogen out, substitute it by NO2 radical, and what is it I get? I get nitro, which I have added to methane, which is known as nitromethane, NM, nitromethane. Therefore, the formula for nitromethane is CH3 NO2, and this has been used, but originally nitromethane was originally used only as a cleansing fluid. Mind you, since the methane is a gas, when you nitrate it, it is a liquid, it is a volatile liquid and has been used as a cleansing fluid. But you know, in one particular accident which occurred in Illinois, in a place known as Pulaski, this was around 1958, you know, the huge wagons which had this nitromethane stored in them, and what happened was when the wagon was being shunted, you had bubbles of air formed in the nitromethane, and you know, whenever we have a bubble of air in a liquid and it is being sloshed, it tends to get compressed, and when it gets compressed it gets heated, and this heat sort of detonated the whole nitromethane, and ever since, you know, we are very careful in handling nitromethane, and it is an explosive. That means we are talking of the first alkane, which is methane, which could form an explosive, and this is known as nitromethane. Let us take the second one. Let us again restrict ourselves to alkanes. Let us take the next one, which is ethane. When we say ethane, well, we know it is C2H4, that is H4 plus 2, H6. And you know, what we do is, you know, when we say ethane, maybe we form, we hydrolyze it to form an alcohol, and this alcohol is known as glycol. And when we hydrolyze it, it forms C2H4OH2. And what you do is you essentially replace the OH by ONO2, that is the nitrate radical, and you get a substance known as OC2H4ONO2 twice. That means I replace OH by the nitrate radical, and this is known as Nitro Glycol. It is not a very popular explosive, but well, it also contains oxygen, it contains fuel, and it can do the job. Let us go to one or two more substances. Let us come to propane. Why I am going through these examples is, you know, even though sometimes the formula for a particular explosive, whether it is a liquid explosive or a solid explosive, may look difficult or may look somewhat unfamiliar to a trained person in explosives, you know, it's all very simple, it's all derived from basics, and it's not necessary for you to really remember a formula for an explosive. It can be just like that written from the structure. Let's take an example. Let's take propane. It is also an alkane, a saturated hydrocarbon. You have CCC H over here, we saw this, equal to C3H8. And what you do is, when you have propane like this, you could hydrolyze it, and you could have something like C3H5. I take 3 of the H atoms substituted by OH atoms, and I form something known as propane triol. And this is propane triol is what is known as glycerine. It has medicinal value, and in fact, you know, when people get an upset stomach, they go and try to take substances involving glycerine. And what you do is, you take the OH, substitute the OH by nitrate ONO2, and you get a substance C3H5ONO2 3 times, which is nitro of glycerine, and this particular substance, which is an explosive, is known as nitro nitroglycerin. This particular explosive has been used for a long time, it continues to be used, and we will take a look at some of these properties. But we must remember that when we talk of nitromethane, we talk of Nitro Glycol from ethane, we talk of nitroglycerin from propane. All these three are essentially liquids. These are liquid explosives. You know, we could keep on going like this. Let's go to one more substance because it's a very popular explosive and quite powerful explosive. Maybe I go to, let's say, pentane. Well, pentane is, let's not write the structure anymore. We now know how to do the structure, C5H12. You know, when I have pentane, I could also hydrolyze it to form alcohol of pentane, very sweet alcoholic drink, which is, say, C5H8 into OH4. This is known as erythritol, pentaerythritol. You know, what we do is, maybe from pentane you get pentaerythritol, I substitute OH by ONO2 to give me C5H8ONO2 4. And what is it we have done? We are having pentaerythritol, in which I have nitrate over here, that is tetranitrate. Therefore, I have pentaerythritol, tetra, 4 of nitrate, which we call as PETN. And this PETN has been used extensively for blasting, maybe in the wars, and this is something derived from pentane. Therefore, we have seen this is a solid, PETN is a solid, and therefore, you know, as we increase the initial molecular mass of the fuel or make the structure more larger, it's more possible that you get a solid out. And therefore, what is it we have considered? We have considered from alkanes 4 types of explosives, namely, we talk of nitromethane, we talk of Nitro Glycol, we talk of nitroglycerin, and now we talk of PETN, namely pentaerythritol tetranitrate, right? You know, let's go to the next one. See, this is from alkanes. Let's take a few from cycloalkanes. When we talk of cycloalkanes, we are talking of cyclochains. Let's just take an example. We talk of cyclo. Let's take an example, trimethylene, trinitramine. That means we are talking of a structure which involves maybe a cyclochain. That means I am talking of cyclochain. I'm talking of maybe chain like this, methylene, CH2, nitramine, NNO2. I'm talking of CH2, I'm talking of NNO2, I'm talking of CH2, I'm talking of NNO2, and therefore, this is 1, 2, 3 tri, 1, 2, 3 nitramine, trinitramine. This is known, this is an explosive, and this explosive is extensively used in the explosive industry. It's known as a RDX, research and development explosive, quite powerful. It does not initiate that easily. We will consider how to make it even more powerful and also consider how to make it less sensitive, but this is what we call as a research and development explosive. It is widely known by the name RDX. Let's consider one more example in the cyclochain, and this is again something which is very popular. We talk of cyclo tetramethylene, cyclo tetramethylene, tetranitramine. You know, when we look at this particular structure, it is have 4 of them. It is something like a box like structure, again a cyclochain, that means we are talking of bent chains, and therefore the type of substance what you have is, maybe you talk of C, CH2, you talk of N, NO2, you again have C, CH2, that means, no, it should have been CH2 over here, right, there is methylene, you have CH2 over here, you have NNO2, you have CH2, methylene, you have NNO2, you have CH2, you have NNO2, and this becomes this. And this particular explosive, which is in a cyclochain with 4 methylene and 4 NNO2 for 4 nitramine radicals, is what is known as HMS explosive. You all would have heard of it. And the abbreviation stands for Her Majesty's Explosive. This is from UK, and that is why the name Her Majesty's Explosive. Which is HMX. HMX and RDX are very commonly used explosives. We look at their properties, we looked at their detonation properties, and well, it belongs to the cyclochain of these substances. Let us take 1 or 2 more examples. Cellulose, let us take an example of cellulose. You know, cellulose is something like paper. The formula for cellulose is C6H10O5. It is a long type of chain. It could be, N could be a large number. You just have a chain like cellulose like this. It could also be written as C6H5OH5 to the power N. What you do to cellulose is you nitrate it, and you have, instead of OH, you replace part of the OH by ONO2, in which you have C6H5ONO2 replacing part of it, let us say X of it is getting replaced, and you have the remaining OH, that means 5 minus X as OH. In the straight chain N is what forms, we are nitrating the cellulose, it is known as nitro cellulose. This is again an explosive, and so on. You know, we could keep on adding other substances to it. It is again a straight chain explosives, and therefore we saw that when we are talking in terms of alkanes and cycloalkanes, we have explosives like nitromethane, nitroglycerine, Nitro Glycol. We talk in terms of PETN, we talk in terms of RDX, HMX, which come from the straight chain. Now, can be from the straight chain and also cyclochain, because RDX and HMX came from the cyclochains. Now, let us take a look at some of the aromatic substances and see whether we could form some explosives. And when we look at aromatic substances, we are talking in terms of maybe the benzene chain, double bond, C over here, double bond, single bond over here, double bond, C over here. And you know, we can talk in terms of, this is hydrogen, 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 C over here, hydrogen, 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 let us put it down, H, 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 that means it is C6H6, which is the benzene chain. If I substitute one of the hydrogen atoms by a methyl radical, I form methyl benzene, which we call as toluene. You know, you will recall in one of the accidents in a ship, we said toluene vapor leaked and caused an explosion. Well, this is toluene. And if we can nitrate this, and how do we nitrate it? Add NO2, and you add something like NO2, 3 of NO2, 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 and replace hydrogen by NO2 here. What is it essentially we are doing? We had methyl benzene, which is CH3, C6H5, and then what did I do? I removed 3 of the hydrogen atoms, and I have CH3, C6H5, that means now 3 are removed, and into this I put NO2, 3, that means 3 of the H atoms are replaced by NO2. what is it I do? We take toluene, and into toluene I put 3. That means I am having tri-nitro toluene, and abbreviation is TNT. This is what is a TNT. It is again a solid explosive derived from an aromatic base, that means a benzene chain, and you have toluene which is nitrated to give you trinitrotoluene. And this is the formula, chemical formula for toluene. Namely, if I put it together, well, I have C7H5N3O6, which is the chemical formula. And this is a solid explosive which melts around 80 degrees centigrade. And what we do is to bring down the power, it is quite a strong explosive, and it is used as a standard for all explosions, and we will be considering about the TNT equivalence after 1 or 2 classes. After 2 classes, we will look at TNT equivalence of all explosions, and this is a standard. It has a high detonation velocity, and it is almost like instantaneously exploding, and therefore it is used as a good reference. Therefore, it melts at 80 degrees, and when it melts, I can add some sawdust or some of these things to make it into a less energetic solid explosive, and this is what is known as a dynamite. You form a lower explosive by adding, you melt it at 80 degrees centigrade. Mind you, this 80 degrees centigrade is way below the temperature at which it explodes, and therefore into this liquid I add sawdust, make a solid explosive known as dynamite. Well, into this TNT, which we said is C6, let me write it down again. I have C7, C6 plus 1 C7, have H5, NO2 3 times. This we said is trinitrotoluene. I want to even make it more energetic. Therefore, what we do is I add C7 H5 into NO2 3 times. I add N of NO2 to it. This is what is known as tetryl. More energetic than TNT, and this is another explosive. That means I take the aromatic base, form TNT, and I add NNO2 to it. Well, it becomes tetryl. Well, these are the different types of explosives. Let us put down the names of 2 or 3 more and then summarize what these organic explosives are like. We take the example, an explosive known as PA, which is picric acid. When I say picric acid, I am essentially looking again at aromatic substances which form an explosive. I am again looking at the benzene ring structure, double bond, C over here. And we said that the benzene ring structure consists of hydrogen attached to all the carbon atoms. Well, I should have had a carbon over here. When I remove one hydrogen atom from this particular benzene ring structure, the substance is known as phenyl radical. If I substitute instead of H, that means if I remove one, it is phenyl radical. If I substitute it by OH, it is known as phenol. We have this smell of phenol. It is used as to clean the washrooms such that it emits some smell, and that is phenol, also known as carbolic acid. Into this phenol, we again add some NO2. That means I add NO2, I add NO2, 3 NO2, I add NO2 over here, and this particular substance is what we call, this particular explosive, when NO2 added to phenol, is what we call as picric acid. Therefore, the formula for picric acid is we have C6, we are left with 1 CH2, C6H2 and NO2 3 times and OH over here. This is picric acid. It is also a good explosive, has a high detonation velocity, and we will consider this explosive also when we talk of characteristics of explosives. You know, we have to look at some more aspects of explosives. We are just looking at the chemical structure of an explosive, because once the chemical structure is there, we can then go ahead, look at the formula, look at whether it is fuel rich, oxidizer rich, whether it could be slightly modified to make its characteristics even superior, and that is what we want to do. Therefore, one last explosive which I will take now is what we call is derived from amines. I think this will complete the organic explosives or explosives derived from hydrocarbons. When we say amine, what we mean is we take ammonia and we take the hydrogen out, we have NH2 radical is an amine, and one such explosive again derived from the aromatic structure, namely the benzene ring, is what we call as Tatb explosive. Let us now put the formula down. Tatb is tri-nitrobenzene. Tatb stands for tri-amino trinitrobenzene. Therefore, now we know what a benzene molecule is. Yes, we can now put it down. I have C over here, double bond C over here, C over here, double bond C over here, have C over here, C over here, 1, 2, 3 double bonds over here. That means I have triamino. That means I am talking of, instead of this I am talking of amino NH2, I am talking of NH2 over here, I am talking of the NH2 over here, and what I do is I attach NO2, 3 of them, NO2, I attach NO2. That means I have trinitro, triamino, that is triamino, trinitro in the benzene chain, and this Tatb is also a powerful solid explosive. Therefore, what is it we have done? We started with the fuels, as it were. We were able to classify the hydrocarbon fuels into different categories like alkanes, alkenes, alkynes, and cyclo of these alkenes, alkynes, and alkadines, which we said, and also we talked of the benzene structure components of these are the hydrocarbon fuels. And when we say, well, these things could combine with ONO2 or NO2, which constitutes the oxidizer, we form different explosive substances. Let's take a look at the different explosive substances which are formed as per this classification. We say we have the organic base which could be aliphatic, namely both the straight chain and the cyclo chain of alkanes, alkenes, alkynes, and alkadines, and also aromatic corresponding to the benzene family. And in the straight chain substances, we form liquid explosives like nitromethane, Nitro Glycol, nitroglycerine. With the solids, we form the penta-erythritol tetranitrate. When we talked of the cyclo ring of these aliphatic substances, we formed RDX and HMX. And when we talk of the benzene ring structure, well, we formed explosives like trinitrotoluene, TNT, which we said from which we get the dynamite. We talked in terms of picric acid. From TNT, we add NNO2 to it and form tetryl. And lastly, we talk of Tatb, which we said is triamino trinitrobenzene. Well, these are all the explosives derived from the organic base. But there are also explosives which are derived from inorganic substances, and we will deal with these inorganic substances. There are not many. Instead of having NNO2, we talked in terms of substances like azides, fulminates, acetylites, and stephanates. These are quite simple, and then we will move into inorganic substances and into slurry explosives and take a look at the explosion characteristics of these substances. We will do the inorganic explosives, slurry explosives, and take a summary of the different condensed explosives in the next class. Well, thank you.